Hello everyone. In this tutorial, we will uh, see how we'll be using the recommender engine that we saw in the previous videos and host it as a service on AWS. Just to give a quick recap of the things that we saw in the previous two videos, we went over the engine.py file, which has all the methods which perform the functions such as get top end recommendations or get the ratings for a particular movie for this user. And then we saw how those methods of the engine are mapped onto the URLs so that when the user hits a particular URL, that is the result that we want to show up. And then we put everything together and run it as a service using CherryPy on our local host and this port 9292. So coming back on this video, we have to see that how we put this on AWS. So let's just type AWS here. This will take us to the AWS website, and so it takes my credentials by default. Okay, so this is the AWS console, and here we can see the different tools that the AWS offers anyone who's signed up on AWS. So the first thing that we look up is the S3. So S3 is basically a service for anyone to host their data. So if we host our application on AWS, we'll need a way for our application to have access to some sort of database on which will perform some tasks, any read operation or write operation, and give back results. So that's where S3 comes in. So we can create a new bucket like this. So we can give a bucket name, um, bucket tutorial, and we can have the, oh, so it says this name is already taken. Let's see if bucket access tutorial. Oh, it must contain only lowercase, so we'll bucket rec sys. Okay, and then we create the bucket. So this creates an empty bucket for us, and then here on we can create different folders, and inside we can keep on creating any uh, hierarchy of folders here. And then when we have a folder where we want the actual data to be, we can click on this upload button here, and then we click on the add files, and then we can browse, select the file that we want to put. Suppose I just put up a PDF here, and then I say start upload, and then it uploads. So it's as simple as that. So for this tutorial, we will need the movie lens data, which can be taken from the group lens website. Just wait for it to pop up. This is not what we want. Grouplens.org, and just the data sets. So these are the basically two. These are the data sets that we want. So this is the small size data set that can be used for testing, and this is the bigger size data. This is sorry, yeah, this is the bigger size data set which contains 20 million ratings that we will use for this demo. So I've already uploaded this data. So because data upload takes some time, we've already put this up, and all of our data is already available. So the mlatest that we downloaded from this website can be put into this folder. So we have the movies.csv and the ratings.csv that we saw our recommender is going to be using. Okay, so once we have our data set up, the next thing that we want to be doing is to set up a new cluster. So for that, let's go back to the console and we will go to EC2, and then, oops, sorry, we want to go to EMR, and then we'll say that we want to create a cluster. MSBA tutorial 1, and then we will make it point to the bucket that we have created for the tutorial. So that was this, and this was the logs folder where we want the logs to be. The next step is we want to give our software configuration. We want our cluster to have Spark, so we'll select this option. We can leave the hardware configuration as it is, and then we'll need to give the, oops, somehow, okay. So there's a problem locating the keys. So you always want to make sure that wherever you're working, you're consistently working in one same zone. So earlier I was in Oregon, so I wasn't able to see my earlier configurations. So I'll go back to North Virginia. I already had things set up. So I'll go to create a cluster, and then again MSBA tutorial rec sys, and then we leave everything by default there. We put Spark as a software configuration. We leave default for hardware configuration, and then we choose the key that we would have set up, and then we create a cluster. So the cluster creation process takes some time, and once it has been initiated, you will see a starting symbol here, and we want to see the waiting uh, message here. That's how we know that our cluster is ready to take requests. Before even the waiting thing, waiting some message appears, we will be able to see this information here when the cluster has started, and we'll have this link for getting the SSH. So so this is precisely the command that we would be needing to be able to make an SSH connection to our cluster. So we'll copy this command here, and so I'll paste it in a temporary place because uh, the name of my key has a txt at the end. So you want to make sure that the name of the key is exactly the same as the key that you have already set up before. And then we'll open the terminal, and also make sure that uh, your current directory has that key. So we saw that the key name was key1.pem.txt. So, and we'll say yes. So when we see this message, that means we have successfully been able to establish an SSH connection with the cluster. Uh, Now, before moving ahead and starting the application, we need a couple of tools to be installed into our cluster. So we want to clone all our code from GitHub. So we want to install Git, and then we want to install Flask and SharePy, the two micro frameworks that we saw in the earlier videos. So we'll install And also we need to install paste, which is the logging tool that we use. So it'll just be very quick, and we'll say yes to that. Okay, so git installation is complete. Similarly, we install cherry pie, and the similar way we install paste and flask. So once we have the set of tools that we need, uh, we want to clone this repository, which has all of the code that we saw earlier. So we can, for this, we simply type git clone, and then we give the URL to the repository that we want to clone. So if we do an ls, we will see the online recommender. That's the name of the repository that is created as a new folder on the cluster. And if we navigate into this folder, we will see that it has the images, the source, and the README. Um, Now we can simply navigate inside the source, and we want to run the server. But before running, let's have a look at the server.py file. So, so like it says, it'll start a service on the local host, but this local host means the cluster itself and on the port 9292. So let's go back without making any changes. Now we can go ahead and start this server. So to run any command to any Python file, to submit a Spark job as a Python file, we type the Spark submit command, and then we give the name of the file. So we'll see that it first initializes all the resources, and then it'll give us the Spark context. And then, like we saw in the server.py, it runs the server, and in that process, it creates the object, the recommender engine object, and once it creates the object, it will also call the constructor, which is the init, where it'll form all the RDDs. It'll train the model. So this is going to take time because it has begun training the model. It should take about 5 minutes. Okay, so we see that it has finished training the data, and we see the engine was started message. This was a printout message inside the ChariPy server. So now we have the recommender engine working, a train recommender engine that has already started on this on the cluster on the port 9292. So let's go back to the console. Now the server might have started, but we still need to provide configuration, and we need to tell that what exactly should happen when a request comes on the port 9292. So for that, we'll go to EC2. We'll go to security groups under network and security. And then we will select this. We'll go under the inbound tab, and then we'll say edit. So this basically contains all the rules that have been defined of how different requests should be handled, UDP requests or TCP requests, and it takes the protocol name, it takes the port number, and then the instruction or on where it should be directed. So we will add a new rule in this. Since we used an HTTP request, we'll leave it as custom TCP rule. We will add this as 9292 because that is the port that we have opened the service on, and that will make it anywhere. So then we will say save. So now the cluster knows exactly what needs to be done when a request comes onto the cluster. But to be able to send a request from a browser, uh, we will need the IP address of the master. So for that, we have to go inside. On the left tab, we will say we'll select instances. So, so in the instances, we want to find the IP address of the master. So this is the public IP address right here. You'll copy this. And now we can use our URLs that we had initially created inside the Flask application to call functions on these. Suppose if we want the top n ratings, we'll add the IP address here. This port was 9292. So what we're basically saying is we want the top 10 ratings for the user ID 1. Go back to this and copy this once again. And then we'll hit enter. So as we can see, when we enter the URL here, we see the server getting at work, starting to work, and it's taking some time, and it is running the recommendation and retrieving the results. And we see, so we see we gave 10 as the count of movies that we wanted, so we have recommendations for 10 movies here. Similarly, if we want the rating for a specific movie for a user, so for that we will enter the URL, and we will remove this, and enter. Again, we see the server starting to work, and we get, so for the movie number 500, that was the movie Doubtfire, we have this rating. Similarly, coming to our third use case, when we want to add another user, so we use this URL. This is the name of the file that we saw earlier, had the movie ID and the rating that the user gave, and then we enter the public IP address and the port number. So I already have this saved. I'll copy this. Also, since we need to pass the ratings file, so we cannot do a get request normally, so we cannot use a browser. We need to do a post request. So there are two alternatives, options that we can take. Either we could use the command line, so we use the terminal, or we can use a REST client for a browser, for example Postman. So for this tutorial, we'll use the command line. Also, make sure that we are in the folder that has the user ratings file. So we go to the source and we see that we have the user ratings file here. So we can run that curl command. So this basically passes the ratings file from this folder into this address. So we see again executor allocation manager. So Spark has started uh, execution of this and it's allocating resources, and then we'll see it eventually returning results. So this step again takes more time because not only we are giving new rating values, we are actually training the whole model again on a on the extended data set. Okay, so we see that the execution has stopped and we see the results. So this gives us the movies, uh, 0 as the user group, because since we gave 0 here, that means we wanted to create a new user with ID 0, which wasn't already there. So this returns a set of ratings for the user number 0 and the movie number and the rating. So we could probably do more processing on this and have the movie name returned instead of the movie number like we did in the other two cases. So that was it. We saw how to host our recommender as a REST service onto our cluster that we created. So before quitting AWS, you should be sure to terminate the application, terminate the cluster. Otherwise, you'd be getting charged unnecessarily. And that is it.